There. Today we'll be going over the remainder theorem. So I will show you what this theorem is about after I've shown you an example. Here is the division that we did the last time from the last video. We tried to divide x cubed minus x squared plus 3x minus 1 divided by x plus 3. And this was the answer we came up with. And so we went through the process, which I'm not going to be able to go over right now. But we went through the process all the way, and we got at the very end negative 46 as the remainder. So, and then we wrote our final answer like this. This is our final answer. Okay, so the remainder theorem says that we could have gotten this remainder, this negative 46, we could actually have gotten that without doing the long process. All we needed to do is to plug in p of negative 3, f of negative 3. So what we're going to do is, this is our f of x. If this was our f of x equals the numerator, all we need to do is to plug in the 0 of this divisor. So if you're going to find the 0 of this divisor, if you set it to 0, x plus 3 equals 0. So x equals negative 3. So what we're going to do is to plug in f of negative 3 and see what we got. So we're going to do f of negative 3 now. So here we go. Wherever we see x, we're going to replace it with negative 3. So it will be negative 3 cubed minus negative 3 squared plus 3 times negative 3 minus 1. So let's take our time to simplify this. That would be negative 27 minus 9 minus another 9, because 3 times negative 3 is 9, and then minus 1. So if we do all these subtractions together, all these negative 27 minus 9 minus 9 minus 1, we'll get negative 46. What this is saying is that if I'm only interested in the remainder of this problem, if I was only just going to get the remainder of this problem when I'm giving this division, if all I wanted is just to see how much will be left over when I divide this numerator by the denominator, well, I don't need to go and do all this process. I don't need to do all this long division process. All I need to do is just go ahead and plug in the 0 of this divisor. Set this to 0, so for x, so we plug in negative 3, and we'll end up with the same answer we will get. That's negative 46. So here is what the theorem is saying. There's the theorem. The theorem says that if you divide a polynomial p of x by a linear factor x minus a, the remainder will be p of a. So what it's saying is, you just need to set this to 0 and solve for x, which will be, x minus a equals 0, x equals a, and then go ahead and plug this a into your given equation. And whatever answer you got will be the same as the remainder you will get by division. So here is another example. Here it is how this is used. So let's say I wanted to divide, I wanted to find the remainder. So I'm interested in the remainder what is the remainder when I divide this example 1? X squared minus 3x plus 1 divided by x minus 1. I wanted to see if there will be a remainder when I divide this, if there is going to be any. Well, I don't need to do a lot of work. I just need to go ahead and plug in. You know, if I set this to 0, so x minus 1 equals 0, so x equals 1. I just need to plug 1 into that. So it will be 1 squared minus 3 times 1 plus 1. This is 1. And then this is minus 3 plus 1. And that would be negative 1. That would be negative 1. So the answer is negative 1. So when I divide this by this, divide this by this, my remainder will be negative 1. In the next video, I will show you why this is important and why this is very useful to be able to do this quickly. For right now, just know that the Remainder Theorem says if you divide a polynomial by a linear factor, remember it's a linear factor, it cannot be like s squared, you know, it has to be linear factor. Then the remainder will always be P of A. If you plug in A, you get the remainder. All right, for right now, this is what Remainder Theorem is all about. I'll see you. Thanks for watching.